Hello class. Today we are going to discuss the detailed solutions of example number 3. Okay, in our partial derivatives part 2. So we're given in example number 3, find the partial derivative of z with respect to x and partial derivative of z with respect to y if z is equal to the product of x to the fourth and sine of xy cubed. Okay, so this is our example number 3 in our latest video uploaded to YouTube. Now we're going to solve the or show you the details of the solution. Alright, so we're given the function z as a function of x and y. We have x to the fourth times sine of the product of x and y cubed. Now if you are going to look at the given class, it looks like the product. It follows it shows that it's a product, and we are asked to find the derivative, partial derivative. So we will use the same differentiation rules. If you can still remember in our previous discussions. So we have here the rules that if you have the product, so the derivative of the product u and v with respect to x, so this is equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. So we are going to use the same rule, but this time we are going to use the partial derivatives notation. Alright, so we can write this formula as derivative of the product of u and v, partial derivative of the product u and v with respect to x. So this is equal to u times the partial derivative of v with respect to x and plus v times the partial derivative of u with respect to x. Alright, now in our given, so this is our u and this is our v. Okay, so if our u is equal to x cubed, x to the fourth, then the partial derivative of u with respect to x is equal to, using the power rule, so this will be 4x cubed. And for our v, where our v is equal to sine of xy cubed. Alright, so the partial derivative of v with respect to x is equal to, so we'll apply the derivative of sine. What is the derivative of sine, class? The formula of the derivative of sine. So the derivative of sine, derivative of sine u with respect to x is equal to sine u times the derivative of u with respect to x, or this is also equivalent to the derivative of sine u with respect to x equal to cosine u times the derivative of u with respect to x. Okay, so we will use the same formula in finding the derivative of v with respect to x for this one. So derivative of sine using the formula, so this is cosine, right? So this is cosine. Our u here is this one, the product. So x y cube. Okay, then times the derivative of our u here is this one. Our u, derivative of u, which is the product of xy cube with respect to x. So take note that we are differentiating it partial with respect to x. So it means y is constant. Okay? So y is constant. This is the product of constant and a variable. So this can be written as, so derivative, this can be written as cosine, you just copy this one, xy cube. Then times, so since with respect to x, so y is constant, so we have y cube times the derivative, partial derivative of x with respect to x, which is this part here. So this part is equal to 1. So therefore, this is equal to, you can write this way because this is just product. So you can write this as y cube times cosine xy cube. Okay, so this is our partial derivative of v with respect to x. Alright, so using this one, we have two problems here to solve the partial derivative of z with respect to x and the partial derivative of z with respect to y. So let's call for our solution. Let us call A. Let's call solution A for our partial derivative of z with respect to x. So this is equal to, so we just rewrite, we have differentiating both sides partially with respect to x. So with respect to x, so it means that y is constant. So just to help you class, remember, when you're differentiating partially with respect to x, so it means that y is constant. Alright, so we have the partial derivative of the whole thing here, that is x to the fourth sine of xy cube with respect to x. So we are differentiating this, and as mentioned a while ago, this is the product. So this is equal to, using this formula, okay, using this formula here. So u, our u here, as mentioned, this is our u, right? So writing our u as x to the fourth okay, then times the derivative of v with respect to x. I will rewrite it first. This is the derivative of v. Our v is sine of xy cube with respect to x, then plus v. Okay, so our v is this one. Our v, this is sine of xy cube, then times the derivative of u, derivative of u with respect to x. So this is our derivative of u with respect to x. Okay, so I will rewrite it first. So derivative of u, which is, sorry, this is x to the fourth with respect to x. Alright, then applying the calculations here. So this is x to the fourth times, so we already have this result, so this one here is equal to this one, right? So just substitute, so y cube times cosine of x y cube, then plus, you just copy this one, sine of x y cube, then derivative of this u, derivative of u with respect to x, partial derivative of u with respect to x, it is times 4x cubed. And rearranging, so we have, this is our partial derivative of z with respect to x holding y as constant. So we have x to the fourth times y cube times cosine of x y cube, then plus, rearranging, you have 4 times x cube times sine of x y cube. Okay, so this is our answer for the first part. Alright, so how about B? So I will use another color for the other one. So for B, we have partial derivative of z with respect to y. So this time, class, with respect to y, so it means that our x is constant. Okay, so again, we have to use the same formula. So this is a product because we'll be using the same function. So this is equal to this time again we have to rewrite, class. We have our u, which is equal to x to the fourth, and our derivative of u. So take note, class, that this time we are with respect to y. Okay, so a while ago we do the u derivative, partial derivative of u with respect to x. So here we have y is constant. You have here y is constant. But this time, for this part, so we are differentiating u with respect to y, so it means that x is constant. So, therefore, if x is constant, then the partial derivative of u with respect to y, x is constant, so this means that this is 0. Okay. Then what is our v? Our v here is same, no? We have sine of xy cube, and this time we have to differentiate v with respect to y. So again, y with respect to y, so it means that x is constant. Okay, so we will use the same formula, derivative of sine u, that is cosine u times derivative of u with respect to, this time we have to use with respect to y. Alright, so with respect to y, so instead of with respect to x, so this time we're going to use derivative of sine u with respect to y, So this is still cosine u times the derivative of u with respect to y. Okay? So it means that our derivative of sine here, which is our derivative of sine u, so derivative of sine is, that is still cosine. Our u is the product of xy cubed times the derivative of u. Our u is this, the product of this one, so derivative of x y cubed, but this time with respect to y. So it means that x is constant. So remember, this is x is constant. So x is constant. Alright. So partial derivative of, so equals, I'll do it equals here. So x is constant, so we'll just take the derivative. It will look like this, class. Cosine of xy cubed. X is constant, so put the constant outside. So times x is constant, so put a constant outside, so times the derivative of, partial derivative of y cubed with respect to y. So therefore this is equal to, rearranging, so we have x times, so derivative of y cubed with respect to y, that is 3y squared. So that is, okay, I will rewrite this one first. So cosine xy cubed times the derivative of this is just 3y squared. Okay, or you can rearrange, we can rewrite this as 3 3x then y squared then cosine of the product xy cubed. Okay, so this is our derivative of, partial derivative of v with respect to x. Okay, so substituting it here, we have again we have using the formula. So this time our formula with respect to y. Okay, you just change this to with respect to y. So this will be u dv, so means our u is x to the fourth times this one, derivative of v with respect to y. So that is equivalent to, or I will rewrite it first, partial derivative of v, or v is sine of xy cubed with respect to y, so x is constant, and plus v, that is sine of xy cubed times the partial derivative of u, which is x to the fourth with respect to y. Okay, so this is equal to x to the fourth. This one we already have solved this one, and this is equal to, that is 3x y squared times cosine of xy cubed, then plus sine x y cubed times the derivative of this, x is constant, so with respect to y, so it means x is constant, with respect to y, x is constant, so x is constant, so derivative of constant is equal to 0, so this is times 0. Okay, so the whole thing here, so this whole thing here becomes 0. Alright? So therefore, our partial derivative of z with respect to y is equal to, so rearranging, we have 3 x times x to the fourth, that is x to the fifth, y squared, cosine of x y cubed. Okay, so this is our final answer. So this is the detailed solution of our example number 3 class in the previous video. Alright, any question? So thank you very much and hope to see you again in our next example. Okay, so bye for now. God bless.